Hello everyone. Today we are continuing on our programming adventure. Today I would have been teaching you guys how to control an RGB LED using potentiometers. But unfortunately, my RGB LED did not work. It was broken unfortunately, and I had to switch LEDs, but I told showed you guys how to like make an RGB LED work. So you guys can actually try out yourself. And I will put the code in description part so you can copy and paste it. Okay, so without further ado, let's get to the assembling process.
The assembling process. As you guys did see, we are going to use this one, RGB LED. So this thing as we call RGB LEDs possess is possessing one red, one green, and one blue LED built in. This one, with it's being marked with little with that bump is red, green and blue in order. Or the best way to understand which one is red, green, blue is to look at the ground pin. The ground pin is the longest one. This one. Let me, yep, this one. The longest one is ground. The thing that left to it is red, green and blue. No matter how you turn it, the only pin next to it is red. In order, red, green, and blue. And we have potentiometers here. We can read an exact amount of data by turning it, as you can see. So, as always, we have our cables, these guys, and these guys. Let me take one. Yes, these guys. One of them has an output, other one does not have an output. In Turkish, we call them male, female. Either male, the one with that little metal, and female without that metal. I don't know what it is called in English engineering, but we call it this way. So, let's just begin. Red cable for 5 volts. This is important. Try to use red or white for voltage. And black for, you guessed it, ground. Let me just, okay. We plug 5 volts in the red one to the 5 volt pin, black one to the ground pin. One of the ground pins. There are 3 ground pins on Arduino Uno. So it is just RGB LED is just the regular LED you can think of, but with a twist. They share a ground pin. And you may ask, what is this? The longest one is the shared ground pin. It directly goes to ground. It gets the leftover energy from this, and this red, green, blue LEDs and sends straight back to the ground. It just makes life easier. So be extremely careful here not to make those legs of the resistors overlap, because if they overlap, they're going to create what we call short circuits and basically fry everything you have. So be extremely careful about it. So for better explanation, I plugged them like this. The red one going to left, like 10 to light left, blue one 10 to right, blue one 10 to light right, and green one is just straight. So our potentiometers have a unique way of plugging. We use these cables. Let me just, okay, now we can continue. So these ones have an extremely unique way of plugging them. So ground, right one, left one, ground, middle one is signal or potential difference, uh, just potential difference, and red voltage. 5 volts here, ground here, and you get in excess, you get the potential here. So for better color coding, this one is the red one. So I will just go ahead and plug a red cable there. And for the blue one, I will plug in a blue cable. Right around here, the middle one, the signal. And our green one. I could not find a green cable, but I don't know why I couldn't manage it, but instead I will just use another color which is not being used, and it is white. If we have used green cables makes life easier since they're color coded. Okay. Red, green, and blue. But we may. Oh, sorry for that weird accent. So, red, green, blue. Let me just make it a little bit easier for you guys. Red, green, blue. So, voltage is this one. When you hold it like this pin is voltage. We plug in 5 volts. We plugged the red cable, voltage cable, into red one. So, voltage here. Be careful while plugging these cables because you may not successfully plug them. Be careful. And the ground. I'm going to use a white one because that color does not matter. It's just a way of. It's just an imagination of your mind. It just makes life easier. It's a quality of life feature of these guys. And you plug the signal cable of the potentiometer into analog pins. These 6 guys. A0, which is labeled by A0 to A5. A0 is the first analog pin. A1 is the second, and thus continues this way. And A5 is the final and the 6th pin. Be careful because pin 4 and pin 5 can also be used for screens. Yes, screens. So be extremely careful of that. Voltage, the green one. Ground of the green one. And the green goes to analog 1. Let me just show it. Analog 1. So, as it turns out, I did not have enough cables. No, I have. Okay. No problem, no problems, no issues. I have enough cables. So voltage of the blue one goes to volts, red, and ground pin goes to ground. Now, the blue cable goes to analog 3. No, analog 2. Yeah. And this wasn't it yet. We still have to plug the LEDs, red, Red one is this. Red, green, and blue. These are the same exact cables I used in the previous episode, so they are working. So be extremely careful where you plug these ones because these are important now. There's a little thing called a PWM. PWM is resembled by this little symbol, and it means you can give or take specific um, specific numbers from them, and it is extremely crucial for RGB LEDs. Otherwise, you're just only going to get red or green or blue or mixture of them or whites. So be extremely careful where you plug them. PWM is resembled by this is I think about it's around equals but with the curve. Yep, equals with the curve. I will put it on the screen right now. Yep, this guy, this one, and our setup assembling process is complete. Now we shall continue on programming.
E coding. So, as always, we are just going to start with int. Just delete this line. It's unnecessary. Int. This time we're not going to write or let green or let blue. We're just going to say int r as 9 to make it simple because I think you understood it. And it is easier this way. R is 9, G is 10, and B is 11. Red pin 9, green pin 10, and blue pin is 11. Now, our potentiometers. Int potentiometer, pot in short, red is analog 0. So while writing this, we say A0. A0 is the analog pin. If a number has A before it, it means it's an analog pin. And Arduino Unos have 6 ones, and for 0 to 5, as I previously mentioned in the assembly process. Now, int potentiometer green as A1, int potentiometer blue as A2. So our basics are done. Now, variables. Our variables are extremely important for this. And the so I'm not writing anything here yet. Void setup. Just delete it. pinMode or output. I'll just go ahead and copy paste it because it is not necessary for me, but please do write them all by hand so that you get used to it. pinMode. Now, potentiometer R is not an output. It is an input. We read data from that pin. And analog pins are mostly used to get data from 0 to 1023 to 1024 different values. So we're just going to use pin input, pinMode, potentiometer, blue, or no, green inputs, pinMode, potentiometer, blue as input. So the things we are going to write down in void loop are extremely important. So first of all, Define. What is define? Fine. And the value we get is value R. We don't put anything in the middle, and analog read potentiometer R, and that is it. So what is define? Define is basically in constant byte something. I don't. It does not matter. Define is an ongoing thing. It will repeat forever. Infinite defining, you may say. We don't put anything equals comma, and we don't put anything here. Just a semicolon at the end. So define value G green is analog read potentiometer green. Define val value blue analog read potentiometer blue. So what is analog read, you may ask? Analog read is when we read a specific number, we get the specific numbers while analog reading. If we are using digital read, we are only going to get 1 and 0, which corresponds high and low respectively. 0 is low and 1 is high. So the next part I'm going to write is the most important part of this entire program. Is degree int intensity R equals to map. Okay, I will explain map value R 0 1023 0 225 2000 255. Okay, what is map? So map is when we use, let's say, analog pins in this example, and we want to get, like, limit that amount we get into another amount, such as 2 255, which is the maximum output or input you can get from a PWM pin. And that's basically it. We change how the algorithm works. Instead of reading each number, each 0, 0, 1, 2, 3, 2023, it makes each four of them count as one. So value R 4 is 1 in map. So to explain yet again, so you can clearly understand it, map is the function we use in order to map a specific number. Okay, what is map? Map is the thing you find treasure, you may say. No, 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 no. Those are A1, A2, maximum B1. No, 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 not those maps are we are talking about. The map I am talking about is limiting map. So limits 1000 0 to 2023 to 0 1055. It's not limiting, but it is just changing how the program perceives numbers. So to use a map, we let me just show you again. Int intensity green is equal to map. So for we say we have 5 different values. Value going to be changed, minimum and maximum of that value, and the previous value, and minimum and maximum of the next future value. So int intensity green equals to map value green, comma 0, comma 1023, comma 0 comma 255. This the one going to be changed, minimum, maximum, the new minimum and new maximum. Let me just say it again. Int intensity blue is map. The value we are going to map value blue, comma, the minimum value of the previous one, 0, comma, the minimum value of the previous one, maximum value of the previous one, 1023, comma, minimum value of the new number, 0, comma, maximum of the new number, 255, or 255 if you want to call it this way. But it is easier if I just call it 255 because I'm used to it from playing Ark Survival. It the people just call 145 level dinos 145s and I get used to it. So our main thing is done. Define value R analog read. Define value green analog read potentiometer green. That's our define. You don't put any equal signs, commas, or anything in between. Just this line and integer intensity red is equal to map value red minimum and maximum of the previous one and minimum and maximum of the new value we are going to get. Our logic part is done. So the rest are extremely simple. It's just basic writing, analog writes. As I mentioned before, analogRead is used for writing or giving specific amount of data, and analogRead is reading specific amount of data. So analogRead is used for giving out specific amounts. AnalogWrite. So the first thing is what is going to change, and it is R, comma, the one being affected and the first one is one being affected and the second one is the value of intensity R. Let me just write it again. Analog writes green intensity green. Analog writes green, no, blue, comma, intensity blue. And our main line of code is done. That was it. We hit the little check mark. Before doing that and being less stupid, I'm using, you can use nano or any one of them you want. Okay, so, oh, okay. You don't put anything after define. I forgot about that part. Define, you don't even put a semicolon here. Just define something as something. No semicolon needed. I am really sorry, programming gods. I am really sorry. I did not mean to do that. I am not a smart soul. So your expectancies should not be as significant. Okay, I will just go ahead and upload our code to our Arduino. Specify it again, Arduino Uno. Okay, and upload. And turn it off a bit. Turn it on. Did I analog read potentiometer? Okay. We don't use define integer. Don't put defines here. Define is just a specific amount. Okay, I really sorry, guys. I just uh, I'm just not as smart as I used to be. I'm just Old man, which is who is 16, is not even 16. Okay, we upload it now. This is our final code, and it should be working, I think. Hmm. Something is not working. All right, what is not working though? Wait, is this LED broken or something? Wait a second. Wait a second, please. I think my RGB LED is not working. Why is that? Did I do something wrong? No, I did not do something wrong. All correct. Something about resistors? No, it is not something about the resistors. What is this? I think it did not upload. I will try it yet again and see if it works this time. I mean, it is supposed to be working. I did nothing wrong there. The program should be working. Here's your value. Here's your value. Yeah, it should be working. I don't know why it's not working. I will take a look at the program and tell you guys which part was wrong. Because troubleshooting is extremely important. If you do not troubleshoot, just going to end up in this situation I'm in right now. Don't be like me. Be more smart. Be smarter, guys. I am not as smart as I'm used to be. I think the thing happening is that um I don't know, right? R in R, intensity R. Um, I actually don't know what's wrong with this code. I actually don't know what's wrong. Did I not define them? I did define them. Value. I actually don't know. I actually don't know what is wrong. It is supposed to be working. Just go ahead and copy paste these guys just in case. It ends here. Why it is not working? Yep, something definitely wrong. But I don't know what is wrong. Okay guys, I will go ahead and troubleshoot. Unfortunately friends, this video will not be an RGB LED. I will change the thumbnail, I will change the video's name, but in the assembling process, I just used an RGB LED, which is super simple. It is extremely like an real LED. I will turn on the camera right around now and tell you guys.
Alright, I am here, and as I mentioned, as it turns out, it is my RGB LED is not working. So that's why I have to use regular LEDs to teach you guys how these guys actually work. And don't be silly like me and try not to control all of them with one And so this one is blue. Don't freak out. Okay. As you guys can see, I can control the intensity of the light blue. Normally, it is super simple. It would have been really good if my RGB LED worked, but it did not work. So think all of these colors mixing. This is the green one, and this is the red one. Let me show it again. The red. Green, I told you to not freak out. Yeah, my cables are not strong cables. Yeah, I'm done. Green, why are you so hilarious sometimes? Green, turn off. I said turn off, Green. Green! I am really sorry, I just get mad when sometimes. I've learned that I sound extremely better, significantly better while speaking to a microphone. I don't know. It's not how I sound in real life, but they say I sound a lot better while speaking to a microphone. And that was it. Thank you, friends, for watching. And I hope you learned something from me. And thank you for bearing my horrible English. Thank you. As I mentioned in the end of every video, please like and subscribe and don't forget to share because I need money. Something little something called the money is needed. It's needed for college. Thank you. And take care of yourself, fans.